Okie dokie. So, algebra 2, if I didn't say it yesterday, I'll just say it again today anyway. Or if I did say it yesterday, I'll say it again today. Algebra 2 kind of focuses on, each unit, I should say, focuses on a specific kind of function, okay? And it's graph, how we can transform the graph, shifting it left, right, up and down, okay? Stretching, shrinking, okay? And then identifying characteristics of the graph, like domain, range, and the end behavior, okay? And we'll talk about increasing and decreasing and stuff like that, I think, tomorrow. Okay, but we're going to focus on domain, range, and behavior today, okay? Each new unit, then, will have a different function that we're going to kind of analyze. After we kind of analyze the graphing of it, we'll then also solve equations that have that kind of function in it, too. Okay? So, before we can get into that analysis part, though, we want to make sure we're all on the same page. We understand how we're going to analyze those functions, how we're going to look at them, how we're going to describe them. Okay? So a domain and a range require us to know what an interval is. Okay, an interval. So an interval is, in math I should say, is a part of a number line without any breaks. Okay. Part of a number line without any breaks. Okay. We can have two different kinds of intervals. Okay, two different kinds of intervals, or two different ways to categorize them. We could say they are finite, okay, finite, which means it has two endpoints. Start and stop. Okay? So finite has two endpoints, a start and a stop. Right? It starts at one place, it stops another place. Okay, that's finite. So if finite's one of them, what's the other one going to be? Infinite. Infinite, right? So yeah, we put an I, we slap an IN in front of it there. And so infinite is the other one, right? So finite has two endpoints. Infinite is unbounded. Okay, so unbounded at one or both ends. Okay, so finite, it's bounded at both ends. It has a bound, right? Like a boundary, right? It has a starting point and a stopping point. Those are boundaries, right? Bounds. Infinite is unbounded, right? Unbounded. Infinite, unbounded, finite, bounded, right? Okay? Unbounded. So that means it goes forever in one direction, or forever in the other direction, or forever in both directions, right? That would be infinite. Okay. So let me show you some different ways to write intervals. So okay, ways to write an interval. We're going to go over three. You can use an inequality. You can use something called set notation, which personally I think set notation is kind of silly because it looks so similar to inequalities. I'm like, why do we bother with this? But you might be thinking, why do we bother with any of this? And I get that. Okay. And then interval notation, I guess I should say. Okay. So you can write an interval as an inequality, you can write an interval in set notation, or you can write an interval in interval notation. Sorry, that's a little mess up there. So I'll show you an example here. So here are some examples. All right. For example, we could write actually, no, let me use numbers here. I think that'll make it easier. Forget that. Okay. There's an interval. 3 less than or equal to x less than 10. Okay. The interval will be all the numbers between 3 and 10. Okay, it's all the numbers between 3 and 10, right? Okay. Would this interval be finite or infinite?
Finite.
Bobby, you said finite, right?
Yeah.
You guys agree with that? Finite or infinite? Finite? Yes.
It would be infinite because it's less than or equal to 3, which means it can be any number past 3.
I see what you're saying, yeah. So this is a bit tricky because of the order here. So you see the x is on, it's kind of like out of order of what we normally see. What we would normally see is something like this, x greater than or equal to 3, right? Because if I take this inequality and like flip the whole thing around, right, the mouth here is still, opening towards the x, like this. But then it's also saying, so if I write it like this, you see now it's x is actually greater than or equal to the 3. And then we also have that x is less than 10. That's what's right here. Do you see how I flipped this around? I took this part of the inequality and I flipped it completely around. It's still saying the same thing, right? Because it's pointing towards the 3, it's opening up towards the x, right? Pointing to the 3, opening up towards the x. And you see the difference there. This, x values are greater than or equal to 3. X values are less than 10. So it's between 3 and 10. So finite or infinite? Finite now, right? Because we are between 3 and 10. See the difference there? Between 3 and 10. What you were saying earlier, we're going to get to one of those just a second here. But this is finite. Yeah, this is finite. Okay? I'll just write it. Let's do another example. X is greater than -3. There's another interval. Finite or infinite? Infinite here, right? We have a lower bound, right? This is the lower bound here. -3 is our starting point, but then it goes forever. Right? X values are just greater than -3, it goes on forever. There's no upper bound, there's no stopping point. Okay. One more here.
Out of curiosity, if it says greater than or equal to, it would still be infinite because it would just be also the chance of equal to negative.
Correct. If you had the equal to part there, you would just include the -3, but you'd still go on forever more than the -3, right? And how about, so here's one right here. Infinite or finite?
I can't see what it is. Infinite. What is it greater than?
See it now?
Less than.
Infinite or finite?
Infinite.
Infinite again. Infinite again. Again, now we have an upper bound, right? 10 is the highest we can go, and it's all the x values that are smaller than or equal to 10. So we're going to go all the way down towards negative infinity, right? Okay. So good. I'll write those up here. So this is infinite. And this is also an infinite.
There's a worksheet for today.
There's going to be some problems from the book, so I'll show you. If you didn't bring your book, that's okay. I'll show you how to access the online textbook. Okay? All right. Set notation, super easy. Super easy. Okay? The hardest part about set notation is drawing this symbol, the brace, right? Okay? Those are really difficult to do. If you have trouble drawing the brace, I would encourage you to think of it like an S and then the number 2. And then you just flip it around. You draw a 2 and then the letter S for the other one. Okay? If that helps. Right? I also teach handwriting in addition to math. Okay?
How do you teach handwriting?
Didn't you guys take handwriting back in the middle or elementary school?
No.
You didn't? I had a handwriting grade back when I was in elementary
You
school.
just told us like if you're bad at it, then you're bad at it.
Okay. Well, back when I was in elementary school, they had a grade for handwriting. And there was a student who skipped a grade because he was like so, brilliant. But his handwriting grade was always like a C or like a D. He had awful handwriting. And then he would get poor grades in handwriting. But yeah, I guess it makes sense they don't grade you on that kind of stuff now. Clearly my handwriting would not get a very good grade either, but it was better than his for sure. All right, set notation, brace, okay? This X and this vertical bar here, okay? This vertical bar it stands for the phrase such that. Okay, so we're describing a set here, just like it's like an interval, same thing. So all x's such that, and I'm just going to use the same numbers here, 3 less than or equal to x less than 10. Okay, so all I did was I wrote this inequality in set notation. Do you see the difference? It's just like the two braces, the x and the bar, and that's it. There's no other differences.
So is the such then the thing that we'd see like a word problem?
This would be, again, you might just, so I'll say this. The majority of the intervals that we're going to write, Bobby, they're going to be in interval notation.
Okay.
So we still need to be comfortable with like interpreting set notation. That's why I show it to you. So if you see it, you won't be like, "Whoa, what the heck is this?"
Yeah.
You'll know what you're doing. Okay. Same thing here. Again, brace x to the bar, and then just rewrite the inequality, and then close the brace. Okay. And then same thing for the other one here. Brace x to the bar, write the inequality. Set notation is super easy. Sorry?
What's the whole purpose of having the brace and all that? If it's
The brace-
literally the same thing.
It's the same thing, right? So why the brace? Because when you deal with sets, the way that you describe a set is you use these braces here to describe.
No, I meant the such that.
Oh, why you write the such that and stuff like that? Because when you describe a set, all right, part of the interpretation here, it's the set of all x such that the x is between. So this kind of like sets limits on our x. So
Okay.
it would just be the set of all x, but I put a restriction on it, say such that the x is between the 3 and the 10 here. So that's kind of like defining the set. Okay? All right, last one, like I said, this is the most important. All right, so if you like tuned me out, you need to tune me back in here because this is the one that we're going to be using the most. I'm going to star it. All right?
You can use a different color pen too.
Maybe I should. You can if you want to. Okay. All right. Interval notation looks a little bit different here. So for this interval that we've got right here, 3 less than or equal to x less than 10, 3 less than or equal to x less than 10, right? We're going to write the 3, comma, the 10. No x in between. Okay? We are going to use special grouping symbols here. For the 3, square bracket. For the 10, parenthesis. Why do I use the square bracket for the 3? Why do I use parentheses for the 10? Huh?
Because he knows that it is 3 and that the 10 can keep going.
Right. So if you look here, right, in the interval, x can be 3, right? X could equal 3, right? That's the equal to part of this inequality symbol, right? Less than or equal to. So I can be 3. Can I have 10 in this interval here, according to this? Can I have 10? No. So this 10, we exclude it. Exclude with a parenthesis, right? Right? Some of us have some painful memories of being excluded or some joyful memories of being included, right? It's like the human condition that we experience there, right? Well, this is not as painful, right? We just have to include some numbers that if they're part of the interval, or we exclude some numbers if they're not part of the interval. Okay?
So include would mean that it would be that number or whatever else it would be.
So include means we count that number,
And
and that's our lowest number. And then 10, we exclude, it's the highest number, right? And every number in between is counted as well, because it's 3 comma the 10. So this number should always be the smallest of the two. This should always be the biggest of the two, right? You go from, from the smallest to the largest, smallest to largest. All right, let's do this one right here. Okay. What's the smallest number in this interval going to be? Negative 3. Yeah, this is where we start. We start at negative 3. Do we include or exclude the negative 3?
Include.
Include? We all agree with that? Are we including the negative 3 here according to the inequality? Does our inequality have the equal to?
Oh, no, I'm sorry. So it'd be
Parentheses.
exclude, and so would the other side.
Comma, and then it keeps going, right? So what should we put here?
The peanut 8.
Yeah, the sideways 8, right? Yeah, infinity. It goes to infinity, right? It just keeps going. It doesn't have an upper bound. Can we reach infinity?
No.
Obviously no. Can we ever get to infinity? No.
Not without adding.
So we can't get to infinity, right? We can only approach it. So we can't get there. Should I ever put a square bracket with infinity?
No.
No, you always put a parenthesis there. You have to exclude infinity because you can never get there. It just keeps going and going and going. It is a number, right? But it keeps going. So you can't get to infinity. You just keep getting closer and closer. All right. So here's one I want you guys. So you guys tried this one right here. Okay, try this one. Okay, so look at these intervals here and write them as interval notation. Okay, so go ahead and try that.
What's the number for infinity?
The number?
Yeah, you said there's a number for infinity.
I mean, no, infinity is a number,
Oh.
but it's different than other numbers. Yes. Okay.
What pages are we on? Just over
It's going to be in the book. It'll be on, I think it starts on page 10, I want to say, in the book.
You guys need to evaluate homework and practice.
Not sure what to do.
Just figure it out.
Yes, it does.
It's going to start there, yeah. Yes, but if you go this direction of the infinity, what infinity would be? Positive infinity, so you're going in the right direction, so you're going in the left direction. That should be. Oh, okay, gotcha. I use paper if you need some, okay? Let me know. You okay? All right. Okay. Okay, good. That's right. Good job. Okay. All right. I see some things here. I'm seeing some things. All right. So, okay. So our number line here, our interval is x less than or equal to 10. So there is our inequality. Okay. Let's think about. Okay, I'm going to draw this on a number line, maybe to help us out here before I go crazy. So I'll put a 10 down on my number line. Okay, we are equal to the 10, so I'll put a solid dot there. Okay, right, because we want to be equal to the 10. We're going to count it. Okay. And then we want to show all the x values less than or equal to 10. So from this dot here, which direction should I go?
Left.
For less than 10, Which direction should I go?
Left.
Okay, to the left, right? For less than 10, so we would go this direction. Okay? This is what I'm trying to describe in my interval here. This shaded space, okay, and you don't have to do this, but if it helps you, feel free to do it. I want to describe this shaded kind of section of my number line here in the interval, okay? So when I describe my interval, I have to go from left to right. Left to right. So this number here and this number here, I have to go from left to right. What's the farthest left this interval goes to? Negative infinity. So I have to start my interval with negative infinity. What's the farthest right my interval goes to? 10. Do we get to 10?
Yes.
Yes. So 10, we put a square bracket. I never get to infinity, so there's the answer. Okay? Negative 10. Okay? I notice a lot of people had like some combinations of this kind of stuff, or something slipped around and all that. Okay? So if you had some trouble, getting the right order and things, feel free to draw this out on a number line, right? Draw your inequality on a number line. Think left to right, left to right. Okay, and that can help you there too. That's what you should have gotten to the interval there. Okay. All right. So let me give you guys a few more here to try. Write the following in interval notation. Okay, so try some of these, and I'll leave that last example up there for you if that helps. So I gave you two number lines to put in interval notation, and I gave you an inequality here to put in interval notation. So see what you can come up with there. I still need to talk about domain and range, so. Yes, and end behavior too. Oh no. As I walk around, feel free to ask questions if you need stuff on something too. Okay, looking pretty good, pretty good. Little things here and there. So, yeah. So watch this one. Which one should be on the left? Which one of these should be on the right? Okay, think about your lowest to your highest, lowest to highest, left to right. So x is greater than 2, but I don't see a 2 here in your interval. Yeah, no, that was right. It was right. right, just in the interest of time here, we'll talk about. There it is. Zoom in on this some. Okay. There they are. Does order matter on in an interval?
Yeah.
Yes. Smaller number first, bigger number second. Starting point first, ending point second. Okay, starts at -3, goes to 2. Starts at 2, goes to infinity. This is a bit harder to see, okay? But if you draw a number line, okay, put 0 in there. We want x values greater than or equal to 0, so I'll put a solid dot and I'll go greater than or equal to 0. That's this direction, right? So you can see we start at 0 and we go to infinity. So it does matter. It does matter, that order there. Okay. And the symbols matter too, right? Solid dot, so we include them. Open circle, right? Open dot, hollow, so it does not include the 2. Okay. Equal to, solid dot, so we have a square bracket there. Include this to 0. All right, questions on any of that? Luke, yes? You're good? You sure? Yes. All right, change your mind. You say something, all right? Let me know. I want to answer questions here. All right, we got to talk about domain and range. Got to get into this. Okay. Got to get into domain and range. Sorry, it's a lot of notes, I know, but I want to make sure we talk about this too. Make sure you're okay for the assignment and stuff, okay? Domain and range. Okay. What do they mean? What do they do? When we describe the domain of a function, what are we looking at? What do we describe when we describe the domain of a function? Domain and range. They go together, right? We always talk about domain and range. Domain describes, okay, how about this? It describes the specific coordinates of our function. And the range also describes specific coordinates.
Is it range like half the domain?
No. You might be thinking about like statistics or something like that, maybe. But describes, yes, domain is the X, Luke, exactly right. Describes all possible inputs, the numbers you can put in, or the X values, if you want to think of it that way too. Yep. Okay. And then the range then, well, what do you guys think that's going to be? It describes all of the what?
The Y value.
Yeah, all the possible Y values. Very good. I'll say all possible outputs for Y values.
Can I go to the bathroom?
Okay. So we'll do 2 examples. We'll do 2 examples here. Describe the domain and range, what I'll say. Okay. Okay, first graph here I'm just going to draw is a parabola. Nothing fancy. My red pen's dying now. Okay, we'll say that's f of x. Okay. If you want to put some like coordinates in, you can. It's not super important for this. So when we go to describe the domain, we want to describe from left to right. When we go to describe the range, it's going to be bottom to the top. Okay. So let's talk about the domain of this function. What's the farthest left this function goes?
Infinite.
So if I follow along my function here, left, I hit an arrow. And that arrow is pointing both up and left, right? It's going to keep going left, which means it's going to go to which number?
Negative.
Negative infinity. So our domain for this function is going to start from the left at negative infinity. Okay? Again, domain goes left to right, so now we're going to go all the way to the right on our function. Right. And we hit
Infinity.
another arrow. It's going up and to the right. So it means we're going which direction here? To what number? Infinity. Positive infinity. And there's our domain. Left to right. Okay, let's talk about the range. Oops, I should have done that.
Huh.
Okay. The range here. Now we're going to go bottom to top. Is the range also going to be negative infinity to infinity?
No.
What's the lowest y value here?
0.
0. 0. Good job. Yeah, right there at the origin. So we're going to start at 0. Do we get to 0?
Yes.
Yes. So square bracket there. What's the highest y value we see?
Infinity.
Arrows are pointing up, right? Goes to infinity. Like Buzz Lightyear says. Right? But not beyond. Buzz Lightyear, I don't know what you're talking about. Going beyond it. Don't know what you're talking about. Just a colloquialism, I guess.
Maybe he did.
Maybe he did. Maybe he figured out a way. Let's try another one. This will be talking about next unit. Okay, next unit we'll be talking about quadratics.
Then why are we talking about it in this unit?
Well, because I have to show you some sort of graphs in order to talk about domain and range, but we'll cover them more in depth later. Okay. This next function we'll talk about later. It's called an exponential function. You might remember these from Algebra 1. Okay.
Yeah.
This would be an exponential growth function here. Different kind of behavior than our quadratic over here that we had, our parabola. Oops, I forgot to put bottom to top. L to R, B to T. Okay. So again, looking at this function, right? Think about the domain. Domain is our x values. X values. Oh, I can't see this up here. X values go left to right. Okay, what's our farthest left we're going to go?
Infinity.
Negative infinity. Thank you. Yes. Yeah. Be careful. Make sure you're saying negative infinity there. Negative infinity. Okay. Right. That arrow shows we're going to the left. All right. Now, what's the farthest right we're going to go?
Positive.
As we go further and further to the right, we're going to keep going right, so it goes to positive infinity. Okay. And the range. Again, range is bottom to top. Now, what does it look like the lowest y value is going to be here? And it might be, forgive my bad
0.
drawing. Yeah, it's going to be 0. It's going to be 0. It's going to be 0. Okay? 0 is the lowest. And does it look like we're actually going to get to 0?
Yes.
Well, eventually, but it would never actually get.
Exactly. It's going to get closer and closer and closer and closer and closer, but it never actually gets there. So we're going to actually exclude 0 from our range here. Okay. In this particular case, with exponential functions, they have that behavior. They'll get closer and closer and closer to it. They'll never actually get there. Comma, though, what's the top of our function going to be?
Infinity.
The highest it's going to go is infinity, Professor. Okay. So there are some examples for you. Okay. I didn't get to end behavior, but we'll stop there just because of time. I want to show you really quickly how to access your online textbook, because we didn't talk about that yesterday, did we?
No.
I don't think we did. So let me show you that real quick. For example, if you took your book home and you left it there, you might be really upset that I'm going to give you homework and you don't have your book to work on it instead.